Hello everyone, my name is Roberto Speranza and I am a PhD student at Politecnico di Torino. In this video I will present the work that I did during my first year of research. As I said, I'm doing a PhD in electronic engineering in a joint program between Politecnico di Torino and Istituto Italiano di Tecnologia. I came from a background in nanotechnologies for ICTs, and my research will focus on integrated energy harvesting and storage system for a sustainable future. But why do we talk about sustainable future? Well, whether we like it or not, our future could look like this, with an always increasing level of technologies in our life. But this road is not free of warning signals. We all know that the CO2 emission growth must be considered when we talk about the future. A future that will inevitably see an increase in the number of connected devices in our life. But a lot of devices also need a lot of energy, and our goal must be to provide it in the greenest possible way. So, in this perspective, I decided to tackle two main research problems. First, the increasing energy demand of a lot of connected devices, with the goal of providing this energy in a sustainable way through solar power, try to recover some of it from artificial light, and of course granting the highest possible level of portability. And on the other side, collaborating with my colleagues at IIT, work on the technologies for the CO2 recycling to high-value products, sustaining the reaction through solar energy. But now that we have our problems, how exactly we look for the solution? Well, of course, I started from the expertise of my research group, where previous work have been carried on dye-sensitized solar cells, with their low cost of fabrication and high indoor efficiencies. For some years now, a significant work is going on energy storage systems like electrochemical capacitors, with their long cycle life and insensitivity to surge fluctuation. And finally, on the IIT side, where my colleagues are working with the recycling of CO2. So, by engineering these tools through innovative designs, we propose novel solutions to tackle the so-called research problems that we set for ourselves at the present time. But let me show you exactly what I did. First, I worked on two devices able to harvest energy and directly store it in a storage section, and able to power low-consuming devices. I fabricated a semi-transparent configuration for indoor application, and a flexible and lightweight one suitable for wearable devices. And then, with the IIT colleagues, we realized the first prototype of a fully integrated artificial leaf able to reduce CO2 to high-value products, powering the device with solar energy. Here, of course, I worked on the photovoltaic module that harvests solar light. And now let me show you some results. Starting from the indoor device, here you can see that the harvesting module shows a very high efficiency when illuminated with an LED light, compared with a simulated standard solar spectrum. For the storage section, the supercapacitor showed a promising cycling stability and coulombic retention. And finally, here you can see the device is able to self-charge to up to 3 volts both under artificial and simulated solar light. For the flexible device instead, the results are promising but still need improvement. As you can see here, the device was able to self-charge exploiting solar power, but the efficiencies are still low and mainly related to the harvesting section. Nevertheless, as the previous case, we were able to obtain an high output voltage, which is mandatory to power common electronic devices. And finally, for the artificial leaf, here you can see that the CO2 reduction cell showed a nice selectivity toward carbon monoxide, which was the desired product, at around 3 volts. So, we were able to realize a solar module that matched the input requirement of the reactor and was able to steadily sustain the CO2 reduction for more than 3 hours. So, to summarize, right now we have an high voltage module for stable solar-driven CO2 reduction, a high voltage harvesting and storage system for indoor application, and a flexible and lightweight powering system for wearable application. Of course, all these devices are still prototypes and will need to be improved to achieve higher efficiency, their materials and fabrication technique will be optimized for higher scalability, and of course new design will be investigated to widen the range of application in the field of sustainable energy. With this, I thank you for your attention and invite you to the next poster days to discover the future development of my research.